for that reheating process. The building has a radiant cooling system. This is a system that is popular in Germany. It is used throughout Europe. It is not used much here in the United States or around the rest of the world. And I believe that it will become very popular in the future because of its characteristics. Radiant systems have the ability to significantly reduce the amount of fan energy that a building uses. And if you take a room like this, for example, this building, designed by SOM, a very good design, uses a standard air conditioning system. It delivers air from the ceiling. It has fans that push that cold air down towards the floor. And some of the air is from the outside. It's mixed with most of the air coming from elsewhere in the building that is being recirculated over and over again. And it would deliver probably about 1.2 CFM of air per square foot of space. There are a couple problems with a standard system, though, and that roughly 75 to 80% of all the air in the spaces come from somewhere else in the building. Well, that impacts the air quality, and that contributes to the fact that 30% of all our buildings are unhealthy. We try to filter that air as we recirculate it, but filters can't catch all the particulates in the air. And if you beef up the filters, it takes more energy to push air through that filter. So so it's a no-win situation. You either have great filters that use a lot of energy or thin filters that don't capture all the contaminants in a building. It also supplies air from above the ceiling, so it has to push that air down to where we are to get that air through our breathing zone. That takes a lot of energy. A lot of the air that comes out of ceiling diffusers will never make it down to the breathing zone. It'll pass along the ceiling by what is called the Coanda effect and go right into return air registers and back to the air handling units located on some other floor in the building. So you have a lot of circulation of air, a lot of fan energy, bringing that air to here and back and so on and so forth without it ever really doing anything of any use. A radiant system works differently. It uses what is called a black body effect. It is an electromagnetic exchange of energy between ourselves and the ceiling. I grew up in the Boston area, and none of the homes had double pane windows. They all had single pane glass, and we used to have a big window in our living room. And we would notice that in the wintertime when it was dark outside, if you stood anywhere near this window, it didn't matter what temperature it was in the house, you would get cold. It could be 80 degrees in the house, and you would have this window would draw the energy right out of you, and you would feel chilly. And that was this black body effect, this radiant electromagnetic wavelength exchange between the piece of glass and the human body. Well, we're going to use that in radiant systems to our advantage. You can exchange heat with people and not have to change the temperature of the air. So by not having to change the temperature of the air and move the air, a lot of energy can be saved. It also allows you to maintain a level of comfort using air temperatures that are warmer than conventional systems. Studies have been done that show that a building that is at 80 degrees Fahrenheit using a radiant system feels the same as a building that is 76 degrees Fahrenheit using an air system. So we don't need to condition the buildings as much to have the same level of human comfort. So here in our building in Guangzhou, we have a couple things going on. We have these radiant ceilings above our head, chilled water pumping through metal panels, reducing the surface temperature of the ceiling so that it can react with the people in the building. And we have this air coming from underneath the floor, this ventilation air. Because our air is for ventilation purposes only, we only require 1/5 the amount. So the pathways for this air are much smaller. Our duct shafts are much smaller. Our fans are much smaller. Because the air is coming out of the floor, it is rising through the space. Natural buoyancy is bringing it through the breathing zone. We don't need fans to force that effect. Because we use this air to breathe and to pressurize the building, and once we use it, we don't need it anymore. It's relieved from the building. So it is a once-through system. And by having this once-through system, we don't have to return all of this air to the building. So if someone down on the 25th floor has a cold, I don't need to catch it. That's a good thing. The overall